Hi there. A viewer recently asked me if it would be possible to provide him with a simple web page to try out the style transfer machine learning model, which I've showcased in my style transfer video series before. Therefore, in response to that request, I've decided to try out Tensorflow.js and convert this model to the format that Tensorflow.js accepts and create also a simple interactive web page, which allows you to use the model without having to do any installations in your own local machine. And all of this will happen in the browser, so you don't have to upload your picture to any website. What are you waiting for? Let's get started. But what is Tensorflow.js? Tensorflow.js is a client-side framework to enable training and inference with a machine learning model directly from the browser using just JavaScript. With Tensorflow.js, we can run pre-trained models originally developed for TensorFlow directly from the browser. And also, we can also train new or pre-existing models with transfer learning using our own data via the Tensorflow.js JavaScript API. Tensorflow.js also provides us with a command line tool to convert almost any existing pre-trained model into a format which is compatible with Tensorflow.js. By the way, Tensorflow.js can also run from a Node.js backend, but for this video, I'm only going to focus on running Tensorflow.js directly in the browser. Why would you want to use Tensorflow.js anyway? Well, one of the main reasons I really never hosted any machine learning models before is because it costs too much. Serving machine learning models as an API from the server side requires me to pay for computing resources, pay for data transfer costs, memory, and file storage. Also, if you are allowing anyone to send you private data, like images, you need to worry about that as well. The last thing you want to do is to store someone's private data and have a data breach. But by running everything on the client side, automatically, I avoid all these problems altogether. And this is exactly what Tensorflow.js allows us to do. Okay, so before we get into depth into Tensorflow.js, let's first try our style transfer model in Google Colab and just make sure that we see it's working. So I'm going to, I'm in the web page for the model, and I'm going to click here in Run in Google Colab. Now I'll connect. So I've connected. Yeah, now I will just have to run the code. Okay. This will download the images from Wikimedia. So that we have here the Golden Gate Bridge, and then we have here this very famous Japanese painting, the Great Wave of Kanagawa. And let's download the model from the TensorFlow Hub, really easy. Now, this is going to be important later, because once we convert this model into Tensorflow.js, we need to understand the signature of the model, what inputs we need to provide and what outputs we get. So it seems like here we have to provide a content image and a style image, and then we get as an output a stylized image. So each image is a 4D tensor. 4D tensor is basically a batched image. It could have more than one image, but in this case, we only have one. So each is a 4D tensor. So this one is a 4D tensor and this one is a 4D tensor. So we could actually process more than one image at a time if we wanted to. Okay, so let's try this very quick example here, and we should get some results. So we're running the model against the two images that we saw just now, these two images. And here, this function here is going to show the result. So this is going to serve us as a guide for when we run the TensorFlow model in JavaScript. Here we have more examples that we can try. Okay, so now let's just try the sea turtle and the very famous painting, Munch Scream, which is very cool results here, as you can see. And we can try more. Yeah. You can see here all these really cool results. Let's try sea turtle again. I like sea turtle. So yeah, okay. So this is it. This is the model. It's up and running. Okay, now what we need to do, we need to convert this to Tensorflow.js. Okay, now that we have tried the model and we've downloaded it, it's all working in Google Colab. it's time to install the Tensorflow.js pip package. This package here is needed so that we can convert our TensorFlow model into Tensorflow.js format, which requires a command line tool that is inside this package. You can also do it with Python code, but I'm not going to try that today. Pip install TensorFlow.js. Let's create another cell, and in this cell, I'm going to create a directory inside content, and I'm going to call it style transfer. I'm going to use this directory to store the new model that I'm going to convert. I'm going to add another cell here, and in this cell, I am calling the TensorFlow.js converter, and I'm passing in as an input format TensorFlow hub, because I'm downloading this model is actually in the TensorFlow hub. I'm passing in a signature name, and this is needed so that the converter is able to identify the function that we want to call in the model, the one that is the main function. By default, many of the models in the TensorFlow hub, they will have a signature name called serving default. And then we have here the URL, which is the URL of the model itself. And then here, this is the directory that I've just created. So what's going to happen is that the TensorFlow.js model is going to be converted and it's going to be stored in this directory. So let's do that. Okay, so the model was converted and it all worked very well. So I'm lucky in a way. So you can see here that now we have the files that are generated for the model. This model is quite large, it's 88 megabytes in size. So we have here the JSON file. The JSON file has a lot of stuff there that, I mean, you can look at it, but you don't necessarily need to understand it. And I don't. And then you have these binary files, smaller files, they're not too big, I think 4 megabytes each. So we need to compress this directory and we need to download it. So let's do that now. Let's see, it's about 81 megabytes now. So I'm going to download this file to my local computer, and then we can go into the next step, which is to create a simple web page and load this model into the web page and try it out. Okay, so I've downloaded the model. I've created the folder that you can see here. So this folder contains my code, which for now it's empty. It's an empty HTML file. And then it also contains a folder which contains the model. And this folder, I've named it style transfer underscore TF.js. You can name it whatever you want. Then you can see all the files here. It's ready to go. Then I've also created 2 files. One is the image, the Golden Gate Bridge, and the other is the waves of Kanagawa. And this is the style image. And these are the images that we're going to use initially just to try and get the model to work without errors. And later we are going to change this page itself to allow you to specify any image that you want. Okay, the very important step that you have to be careful about is that, okay, you need to copy and paste this script tag from the TensorFlow website, but you need to modify it as well. I'll show you. I'm going to paste the TensorFlow scripting code, and you can see here the version number is 2.0.0, and you need to change this because version 2.0.0 doesn't support many TensorFlow operations that are, for example, used in other TensorFlow models, and you would get some really nasty errors if you don't do this. So this is really important. Another important step is that if we try to run this directly from the browser without having a web server, it's going to give us a nasty error as well. So what we're going to need to do is we need to actually run a small web server locally in our computer to be able to run the code, the JavaScript code without any errors. To do that, I actually use Docker. You don't have to use Docker, but you can use any other method you think is better. All you need is a server running in your local machine. And I will share with you the method I've used for Docker. I'm on a Windows machine, so I need to run actually a VM to start Linux. So in this VM, I have to start Docker. You need to do Docker run. Then you specify the port numbers. In my local computer, I'm going to run my web server in my port 8080. And then in the container runs in port 80. So you need to map your port 8080 to port 80. Then I specify the actual folder where all my code is going to be located. And then I map this folder to this folder here, which is a folder that's used by the Nginx web server to serve files. You just have to run this and things will happen automatically. Okay, it's already running for me actually. And now I should be able to access the web server via localhost 8080. Okay, but because I don't have an index.html file, it says forbidden, but actually I have a file called intro.html. So here I have an empty web page. It only contains the script include for Tensorflow.js, and hopefully there's no JavaScript errors. Ignore this one here. It's just because I don't have favorite icon. I don't see any JavaScript errors, and that's a good sign. You should be able to create any page in that folder. You can call it whatever you want. Right. So before we try to do anything fancy, we should just validate that our Tensorflow.js framework is working correctly. So what I'm going to do now, I'm going to copy a snippet of code which comes from one of the Tensorflow.js tutorials. And this snippet of code is going to create a simple model with a couple of layers. And this is just to validate that the API works fine. But I'm not really looking to do anything useful yet. So I've just added the code here. Make sure it's not commented out. So let's do this. So I'll go back to the web page, refresh it. And it's looking good, although this annoying error is still showing up, but ignore it. So you can see here, there's a tensor that has been printed out. This is good sign. So it means we can go to the next step. So now we need to understand that the model that we've downloaded from Google Colab was its original model saved using TensorFlow saved model format. The way we deal with models in TensorFlow is different. There are two methods to deal with models in Tensorflow.js. There's one method, which is, in this case, tf.loadGraphModel method. And this method is used for the TensorFlow saved model. And then you have another method, which is used for models from TensorFlow Keras, which we are not going to try today. But I'm just going to give you the name. So it's the tf.loadLayers model. And this method is only used when you are using this type of models. For us, we only need to call the load graph model. So let's try and load our model. Hopefully it will work. So I'm going to delete this for now. And I'm going to just paste this line here. So I have a directory which has the model. It's called style_transfer_tf.js. And then inside that directory, there's a JSON file, which is called model.json. And this is the file that you need to load. And everything else gets loaded once you load this file. Loading a model of this size actually is going to take a few seconds. So it's normal that it's a bit slow. So let's reload the page and hopefully there's no errors. No errors. So now that we've hopefully are loading the model, now we should be able to do something with the model. So let's try and make a call to the model. But before we do that, we need to prepare the data because the model needs images and we have none right now. So I'm going to create two simple HTML images that we can feed that into the model. Okay, so I'm going to add some HTML to my page. So it needs a body. And I need to close the body tag as well. And I need to close the HTML. Okay, what I need to have here is an image, first of all, and I'm going to give it an ID so I can call it later from JavaScript. And this ID is going to be, I'm going to be very imaginative, and it's going to be called image. So I need to provide a path. a source. So the source is going to be like image.jpg, right? So this is the image that I've already copied inside my folder. You can also have your own image. It doesn't have to be the same. So I'm going to copy and paste this. And so this is the image, and this is going to be the style image. Okay. And then style image. I think style image.jpg. Yeah. So one image is going to be the image that I'm going to apply style to, and the second image is the style image. Okay, I can see the first image is working correctly. The second image doesn't work, but that's probably because I forgot the actual name. I'm just going to copy and paste the path here. So now I should be able to see the image. No, yeah? What happened there? I forgot the extension, of course. Okay, so now I have two images. It doesn't look very nice, so I'm going to add some limits. So I'm going to set the width to 500. I'll leave the height. I don't want to deform the picture, so I'm just going to set the width only. Okay, now I should be able to have some decent sized image. I can see both of them side by side. Then later on, I'm going to tidy this up a little bit more. No, not too much though. Okay, now we have the images. I need to convert these images to a tensor, and there are some functions available in TensorFlow to do that. One of them is from pixels, which is tf.browser.fromPixels. This method is going to allow me to convert an image which is in pixel format into a tensor format. But before I can do that, I need to do actually some pre-processing of the images. So I need to work on that next. To invoke the model, we're going to use tf.graphModel.execute. The execute method takes as a parameter the inputs to the model and an optional parameter, which is the output node name. This is basically the name of the node which will contain the results from executing the model. If you leave it blank, it's going to default to the default output node. So we don't actually have to use it. So what this execute method returns as the stylized image, which is going to be available as a tensor, which we need to do some conversions, and then we need to display it in the browser. So now we are going to be working on pre-processing function because we need to convert our images into a tensor. So let's do that. So I'm going to create a function here called an async function. It's important because all the sync methods I'm going to call are asynchronous. And this function is I'm going to call it, what can we call it? I'm going to call it do style transfer. Okay. And for now, no parameters. I'm going to be calling the model. I'm going to create another function for loading the model. So I'm going to return. So instead of doing it here in the body, I'm just going to do it inside the function. So return. Okay. So I'm going to save the model. So const model equal to tf to load model. And then the idea is we call the execute method. Okay. For now, I'm going to comment it out. So just to make sure that this is still working, I'm going to add onload here, and I'm going to call this method load model. Sorry, do style transfer. So as soon as I load this page and it's ready, the do style transfer method is going to be called, and we'll be executing this code. For now, I just want to make sure that I'm not getting any errors. So I'm going to refresh the page. Probably I'm going to get JavaScript error. That's what you normally do. I'm a bit surprised that there are no errors. But yeah, there's not much we are doing anyway. So I think we just have to wait because the model, loading the model can take a bit of time. Okay, there's no errors there. So just to be sure that something is happening, I'm going to do a console.log. So model equal to model. So now I know that something is happening. I'm not sure if anything is happening, but do not despair. We can also do a console.log from outside. Hello world. I just want to see some life here. Okay, hello world is showing up. So I'm going to do another one here as well. Do style transfer call. No, it doesn't seem that it's working. Okay. So maybe I've added this to the wrong place, actually. It shouldn't be on the script tag. It should actually be in the body tag. So anyway, with some debugging, I figured out I was doing the wrong thing, which is great. And now we get to see some output. So we have the style transfer code, and then we have model, which is a promise, not an object. So because I'm already in an asynchronous function, I think I can do an await here. Let's try. And I should get the actual model instead of a promise. Okay, now I get the model, so I should be able to call methods on it. Okay, so the next step is to do some pre-processing. And what I need to do, I need to load the image from here into a variable, right? And then I have to call some TensorFlow methods. First, I'm going to get the first image. So document.get element by ID, and I pass in the ID, which is image in this case. Okay, and then I have to also get the style image, and I'm just going to rename the variables to style image. Okay, so I have the two images here, and now I'm going to pass it in to the preprocess function. So the preprocess, I'm going to call preprocess for first image, and this is going to return me image tensor. Okay, and then I haven't written the method, I'll write it in a second, and then I'll do the same for the style image tensor. So let me add const. Okay. Okay, so we have here the two tensors, and then we'll call the method. We'll call the model with these two tensors. For now, I'm not going to go any further, not calling the method just yet, but I need to write the preprocess method here, which should be not too difficult if you know exactly what to call. And yeah. Right, so it's going to take a parameter, which is going to be the image data. Yeah. Okay. So it takes a parameter, which is the image data. And the first thing we need to do is we need to pass in, call a method called tf.browse.from pixels. And this is a method provided by the Tensorflow.js library, and it's going to convert our image data into a tensor. Okay, so I'm going to create the image tensor here. So let image tensor equal to tf.browse.from pixels image data. Okay, the next thing we need to do, we need to normalize this image, because this image has 3 channels, and the values, they vary from 0 to 255. But for Tensorflow.js, it needs those values to be between 0 and 1. So we need to apply a step of normalizing the data. So in this case, I'm creating an offset using TF.scalar and passing the value 255. And then the idea is we use this value and we divide every single pixel inside the image by 255, and then we get a normalized value between 0 and 1. So simple enough. Okay, the next thing we need to do is we need to add this image to a tensor with 4 dimensions. And the extra dimension is needed because the model itself will be able to accept 1 or more images. So it expects an array of images rather than a single image. So what we're going to do, we're going to fake this array. We're just going to create a 4D tensor with 1 element in it. So const batched equal to normalized dot expand dimensions, and I pass in 0 here. And then I return batched. And this is going to be the tensor that the model is going to receive. So here I have a tensor for the image, and then I have a tensor for the style image. And now I can just call model.execute image tensor and then style image tensor. So I need to pass this as an array like this. So let's give it a go and see what happens. Okay, so we're getting an error and it didn't like the from pixels method. So let's see why. TF adds browser, I think. So I missed character. Okay, I need to change this to image tensor, because I didn't have to resize this image, so it's just going to be the image here. So let's try again. Okay, so now it seems like there are no JavaScript errors, but I still don't know if anything happened. So I'm going to store the result and then print it. Actually, there is a very handy function here. You can just do .print. Okay, so we can see there's a tensor being returned, and this is going to contain the output image with the style that we want, hopefully. And what we need to do now, we need to actually display this in our HTML page. So for that, I'm going to create a canvas, and I'm going to use another TensorFlow utility method, which will take this tensor and is going to write that into the canvas as an image. So let's do that. So canvas ID equal to stylized, I can call it stylized image. Okay, so we have an ID stylized image, and then we have to pass in source. No source. I think you just have to pass in the width, and I'm going to pass in width of 500, and then I have to pass in also a height, and this height is going to be also 500. The image doesn't necessarily mean it's going to be 500. It's not going to be a square, but I'm just giving it the maximum. It's going to be at most as big as 500 by 500, the image. Okay, so now we have a canvas. So let's see if this canvas actually works. Okay, I can see there are no JavaScript errors. I don't know if the canvas is actually, yeah, it's there. Okay. So the canvas is there. So now I need to use tf.browser.2pixels, which is going to convert our image, which is in tensor format, to pixel format. And this tensor here is going to be also 4D tensor. So I need to remove one of the dimensions because I know that's only one image there. So I'm going to use for that tf.squeeze, and I'll pass in the result, which was returned from the model. Then I had to pass in the canvas. So the canvas, which I need to retrieve first. So let's do canvas, let canvas equal to document.get element by ID. And I pass in the canvas ID, which is stylized image. Okay. And now, I don't know what's going to happen, actually. Do I have everything I need? Let's try it. Okay, I need to make sure I check the JavaScript. Okay, so I get an error because I'm passing a null instead of an object. So I'm not getting... Oh, I see what's going on. Okay, so I need to remove the print statement, and so that it can store the actual result of the model in result. So let's try again. So now, okay, I got some result, but this looks a bit odd, right? It feels like the actual Golden Gate Bridge was used as a style image for this image, so it was swapped out. So maybe I passed the parameters in the wrong order, so it maybe expects the style image to come first in the list and then the image that I should style. I'm going to take this out. Oops. So here, I'll remove this. Control X. Okay. So what I get now, hopefully it's going to be a better result. Okay, so this is much better. Okay, this looks like the normal, what I would expect to see. Maybe not as nice as the one we saw in Google Colab. Let me just check, compare it. It's a bit different, to be fair. The results are slightly different, but it's better. Okay, this is similar to this style. Okay, what I want to do now, I want to make sure that I can actually pick any images I want, and I can try out freely like this model without having to hardcode the images as we have now. But we've done very good progress, and now it's basically time to just do some front-end development. So I've added some extra functionality into the page. I didn't want to waste your time on it because I'm not really here to teach you HTML. And this HTML, trust me, is not really that nice. Anyway, I added some JavaScript, some HTML. So I added the 2 input elements for the files. So now you can pick a file here, and you can basically apply a style to whatever image you pick, so that at the top you can pick the image you want to stylize, and then the second image is basically the style image, and then at the end you get the result with a style that you applied. And all of these runs in the browser. There's no need for TensorFlow to be installed on your machine. It's really easy. I hope you found this video useful, and if you did, please don't forget to click the like button. This will tell me that this type of video is something you enjoyed, and then I'll try to make more videos like this so that you can learn coding and have some fun in the process. Happy coding! Bye-bye.